Alright, recording. Here is the answer video for spot check number 30, the lesson quiz that you guys took yesterday and today. I didn't put a period in there because I used the same function for all three classes. Sorry. So factoring completely involves when you have difference of two squares, both these terms are perfect squares, use the formula to factor the square root and plus and minus. So then you do that once to factor completely. This again is another difference of two squares. It becomes x plus 2 and x minus 2. Remember that if I was to just multiply these two terms and back up and collect like terms, the middle two x's would be canceled out. That's why these two terms factor into two binomials of two terms each, plus of 2 and minus 2. Now we have to sketch this. You have to do some analysis on the roots, set this equal to 0 and solve. You will find out that you have two imaginaries. Remember, you're taking the square root of a negative. That means you have imaginary roots. This two roots with the zero product property are negative 2 and plus 2. We look at our original function and analyze end behavior. We see positive and even, so that's up, up, with a y-intercept of 0, negative 16. And like we talked about in class, this is an even function, so even though there are two imaginary roots, you really can't draw it on the graph. So we make it like a flat parabola and make sure it goes through points of interest. Over here on question 2, it's a sum of cubes. X cubed is a perfect cube because x to the third power, and 2 to the third power equals 8. So I wrote that just to show you what they were there. So we follow the pattern. We find the cubes, x plus 2, and then square this, change the sign, multiply them together, and then square this. So now we've decomposed this higher order function to these two functions. Again, zero product property to find that root. Look at the leading term of the the polynomial to determine end behavior. Do b squared minus 4ac on this trinomial to analyze the types of roots. You will find out again you're taking the square root of a negative number. That means this is going to give you two imaginary. And then when you graph this, up here it says the y-intercept is 0, 8. I don't really care where you put an imaginary turn on the graph here, just as long as you put one there to illustrate that there's two imaginary roots and it goes through the other 2 points of interest, matching our correct end behavior. That's it.